Hi, welcome to today's video. We're going to talk about CHM256 about volumetric analysis in pharmaceutical fields. So, what is a pharmaceutical? Pharmaceutical is a field where we use drugs to synthesize medication for sick or ill people in the hospitals or clinics or other buyers. So this is useful widely in our humans systems body to help prevent illness or everything. Okay, so let me introduce myself. I'm Minin, and we have my friend in crime Ekal, Roy, and Hazim. So we're going to take a look deeper in. So what is it volumetric analysis? If you ask me, it is a quantitative analytical method to determine concentration of substance in a solution. So it involves measuring and volume of reagent of known concentration. So common process is actually titration, whereby titrate added into solution until reaction is complete. Indicate by color changes using indicators. Usually titrant is actually a strong base or a strong acid. We cannot use weak acid or weak base. An indicator we usually found in our lab is actually phenolphthalein, methyl orange, methyl red, methyl blue, and so and then the volume of titrant is then used to calculate the concentrations of the analyte. And we go to into importance, actually accuracy, precision, simplicity, and efficiency, versatility, cost-effective, chemical applications, and regulatory compliance. Whereas we're going to take a look deeper today. We're going to look at two things: quality control and also quality testing.
Firstly, the uses of volumetric analysis is in the quality control of pharmaceutical products. Quality control is a rather important step in the production of pharmaceutical medicine because when it comes to health, everything has to be highly precise. This is to avoid harms or unwanted side effects, and it is especially true for oral medication. However, there are still some downsides to using volumetric analysis as a form of quality control. As good as a scientist can be during analysis, the procedure can still be affected by the quality of the lab equipment and by the environment in the lab, such as humidity and temperature. Although the latter can be rectified and controlled, it is ultimately unavoidable for a small amount of foreign contaminants to contaminate the product during analysis. As to why it is preferred to use volumetric analysis as a form of quality control, it is mostly because it is relatively cheaper compared to other more complicated methods. This is because it doesn't require a lot of lab apparatus or chemical reagents. It is also a rather simple procedure to carry out, which reduces the likeliness of accidents from happening during analysis. As a cherry on top, it is also relatively accurate, which is something that is preferred in a quality control analysis. Regardless of the uncontrollable factors, in the end, it is still very important for scientists to be as thorough and as disciplined as possible during the analysis of pharmaceutical product as to ensure the best possible qualities. The reason volumetric analysis is used is because it is able to determine the exact compounds are present in a pharmaceutical product. This is important in ensuring the correct compounds are present in said products. Another reason is to measure the purity of a certain compound in the product as to ensure it is up to par with the standards.
Next point, volumetric analysis is also used in quality testing. It means that through volumetric analysis, we can monitor pH levels to make sure that the pH level remains stable in optimum condition in order to increase the sample's shelf life. Other than that, volumetric analysis is also used to validate the stability of formulations by identifying the concentration of active ingredients. One might ask, what are the pros and cons of using volumetric analysis? Well, since everything has its own strengths and weaknesses. This also applies to the volumetric analysis. The benefits are volumetric analysis offers precise and accurate measurements while being inexpensive in terms of cost. It also requires minimum sample preparation, so it can reduce the risk of contamination. The downsides of volumetric analysis are it requires calibrated equipment in order to achieve accurate measurements. Other than that, since it is handled by human, it increases the risk of human error. Lastly, in order to achieve accurate measurements, only skilled handlers should perform volumetric analysis since it requires skill in order to not mess up the analysis.
Hi, I'm Roy and I'm going to explain the methodology using titration technique in synthesized aspirin. This methodology consists of two parts, which is standardization of sodium hydroxide with potassium hydrogen phthalate and determination of the purity of aspirin tablet. The first step is the burette was rinsed using distilled water and the burette was filled with sodium hydroxide solution. Obtain and prepare a burette for titration by washing and conditioning it with titrant and solution. The second step is the initial burette reading was recorded after the burette reading reached 50 ml. 0.8 gram of phthalate was inserted in a clean 125 ml conical flask. And then the acid was dissolved in a 50 ml of distilled water. 3 drops of phenolphthalein was added in a conical flask. And next step was the sodium hydroxide solution was transferred gradually into conical flask. At the same time, the conical flask was swirled to react with the phthalate. And the next step is the titration was stopped when the indicator changes from colorless to light pink. And the final reading burette was recorded and the titration was repeated for the second one. The molarity of sodium hydroxide was calculated using the calculation below. The next part is determination of the purity of aspirin tablets. The first step is the aspirin was weighed between 0.10 to 0.5 gram and was placed into a 250 ml flask to the precise mass and was recorded. 10 ml of 95% ethanol was added into the flask and the mixture in the flask was swirled for a few minutes to let the mixture fully dissolve. 2 to 3 drops of phenolphthalein was added into the flask and slowly the mixture was titrated using the standardized sodium hydroxide solution. The initial and final burette reading was recorded. The titration was repeated for a second time and the moles of the acid found and the percent difference in percent purity of the closest two trials were calculated using the calculation below. In conclusion, volumetric analysis plays a crucial role in pharmaceutical industry by providing an accurate and reliable measurement of substance in formulation and process like titration and other volumetric methods. Also, pharmaceutical companies ensure its purity and quality of their product that ensures that it will aid the efficiency for patient use. That's all from us. Thank you.
I'm a girl about a 10. I should fuck her in the Benz.